floating point types. Let's go ahead and open floatingpointtypes.cpp. I'm going to make a working copy of that and paste it into our working project. And I'll go ahead and open that up. And we'll double click on this so we can see the whole thing. C and C++ provide these basic floating point types. We have float, we have double, and we have long double. And you'll notice that we have some cout statements here, which are listing simply the size in bytes using the size of operator of each of these different types. So let's go ahead and run this. I'm going to double click on this to bring it back to our regular size. And I'll go ahead and click the green compile and run button. And you see here the size of float is 4, the size of double float is 8, and the size of long double float is 16. And those sizes are in bytes, so for bits you would need to multiply that by 8. And so the float size is 32 bits, which has a precision of about 7 digits. So while it may be possible to represent some very large and some very small numbers using floating point types, the precision is always limited by the size of the variable itself, the number of bits that are available to represent the floating point number. So a 32-bit float is going to have a precision of about 7 digits, and a 64-bit float, which is the double, is going to have a precision of about 16 digits. The long double is a standard IEEE size, which has about 80 bits, at least on GCC it is. On some other platforms, it's simply an alias for double. Like for instance, in Visual C++, at least the last time I checked, long double was the same as double. The thing that you need to remember about these types is that while, again, you may be able to represent some very large and very small numbers, the precision is sacrificed. So for example, if I come down here and I'll initialize and use some of these, let's say f equals 0.1. Then I go ahead and I add to it, I'll say f plus equals 0.1 plus 0.1. Now we would expect the value to be 0.3, and I'll go ahead and I'll print that out. F is, and F, and L. And if we go ahead and compile and run this, you'll see it says F is 0.3. Well, here's the interesting thing about this. If I now say if F equals 0.3, and that's the literal constant 0.3, then I'll go ahead and I'll say cout yes. And if I say else, cout no. Now, given that it says F is 0.3, we would expect to get a yes here, right? And given that I asked that question, we might maybe expecting something else. The answer is no. Even though it's displaying as 0.3, all the way out to the amount of precision that it has, it is not quite exactly equal to 0.3. And we could print it out and show you how many digits it is, but that's not really important. This is one of the lower precision versions of this that we have. What's important here is for you to know that if you're doing something that requires actual precision, something like accounting, it requires a specific number of precision, requires that rounding be handled in a specific way, then you don't want to be using floating point numbers. You want to be using one of the integer types. So C and C++ provide a few standard floating point types, and while it's possible to represent very large and very small numbers with these types, it is at the expense of accuracy, and you need to be aware of that. If precision is important, as in the case of accounting, you want to use an integer data type instead. So let's go ahead and delete the working file and run clean to get set up for the next lesson.